The research activities of our group are focused on the design and the formulation of new materials based on thermoplastics matrices, including biopolymers and recycled polymers. We operate in different fields such as recycling, valorization of waste, and bioplastics. We study mechanical recycling strategies for polymers recovered from different streams and production scraps, such as automotive demolition chain, food packaging, waste from electrical and electronic equipment. To recycle plastic materials, sorting is mandatory. The material is then shredded into flakes and melt processed to obtain new products. Our labs are equipped with extruders and mixers at different scales, allowing the processing from tens of grams to few kilograms of material. During this process, the recycled materials can be added with several additives required for the final application. The obtained material can then be used for several transformation technologies, such as extrusion, film blowing or cast extrusion, injection molding and 3D printing. Our labs are equipped with a 50-ton injection molding machine for the production of specimens and objects up to 60 cubic centimeters per shot. We are able to study innovative solutions for mold thermoregulation and surface finishing. The process can be also studied and optimized using advanced simulation software. One of the most distinguishing characterizations of our laboratories lies in the flammability tests. We can also analyze both the degradation residues by ATR and the gaseous products by GCMS or TGA, FTIR. The combustion behavior can be evaluated by cone calorimeter test. It detects the time to ignition, the heat developed and the quality and quantity of smokes. Research in our labs has focused on producing filaments for 3D printing fused filament fabrication process, from recycled materials like urban waste or surgical masks. Surgical masks are mainly made of polypropylene, one of the most widely used and easily recyclable polymers. We are able to process the material through extrusion, injection molding and 3D printing. Our labs are equipped with 2 filament makers and an FFF printer with dual extruders and hot chamber. Optimizing the material and the processing conditions, we obtain objects with specific functionalities, such as thermal conductivity or flame retardancy properties. Furthermore, the mechanical properties of the 3D printed parts are evaluated through thermomechanical analyses, tensile, compression and flexural tests. In our labs, we develop materials based on biopolymers and composites containing natural or bio-sourced fillers, like rice husk, nut shell powder, and biochar. We have produced materials filled with rice husk, considering thermoplastic and thermoset polymers. It is also possible to produce biopolymers-based films by cast extrusion or film blowing. The processability of the material is assessed through an elongational rheometer, and the processing conditions are optimized to study the film properties as a function of the draw ratio. The processability of the materials, as well as the microstructure properties relationships, are assessed through rheological analyses. Besides, the obtained films can be characterized depending on their future application using different spectroscopic techniques, such as UV-Vis, FDIR, Raman. Our labs are also equipped with a photoaging testing machine to study the aging mechanisms of polymers exposed outdoors.